Hello and welcome to my load calculation video on multifamily dwellings using the standard method and also finding the minimum overcurrent protection device. I'm going to first go over a summary of all of the rules, which is going to simultaneously show you how to fill out your sheet of paper in order to do this load calculation. The first thing I'm going to point out is that I have in parentheses X units. So since we're dealing with a multifamily, we're going to need to multiply everything by the amount of units that we're working with. So when I go over the summary, I'm not going to be actually showing you an example yet. The second part of this video will have a question with me actually walking through and filling in the answers, which is going to ultimately conclude in the total demanded load for those multifamily dwellings. There's also going to be some helpful tips and tricks along the way. Just like all times when you're doing load calculations, make sure to have your National Electrical Code book. I'm using the 2020 edition, which is going to cover 2017 and 2020. If you happen to be using the 2023 version or are tested on the 2023 version, then everything in this video will teach you almost everything you need to know. There's just a few more additional things that might be in a 2023 load calculation. This video is still going to teach you the basic idea of how to fill out a load calculation for multifamily dwellings. All right, let's get into it. When we're trying to find the minimum overcurrent protection device of multifamily dwelling units using the standard method, this is how we're going to do it. Of course, we're going to get the square footage of the house, and we're going to times that by 3 volt amps because the code book tells us we need 3 volt amps per square foot. When we multiply our square footage by those 3 volt amps, we're going to get a number I'm just going to call N. Then every time, if there's no exceptions, we're going to add a 4,500, and of course those are going to be volt amps, to that first number that we got. So we're going to add those two together. This number comes from 2 small appliance branch circuits and 1 laundry circuit, which is the minimum mandatory circuits that you need for a dwelling unit. But be sure to check out my residential load calculation video part 3, because that's going to share with you if there's an exception to not include your laundry, then you're going to know where to find that in the code book and understand it, so you're going to know what to do if that comes up at any time. Okay, and they might also mention to not have housing loads when you're doing multifamily dwellings. I'll get into that in a second. For now, we're still at this section here. We have our square foot times 3 volt amp. We have our number. We add 4,500 to that. Of course, that's going to give us a number, adding those two together. But from there, we have a certain amount of units. So we need to multiply it by the amount of units we have. And when we do that, with the standard method, of course, we're not going to be done here in what is called this general lighting load portion of the load calculation. I don't want to get too crazy with the arrows, but I'm going to redirect this over here. After getting this number here and multiplying it by the number of units, we're going to have to do the demand factors for the general lighting load portion, which are pretty complicated. So of course, I'm going to get into that in this video. But if you want a more in-depth explanation, if you don't understand the demand factors for this portion for some reason, check out the residential load calculation video part 1. All the videos that I mentioned in this video will be linked in the description, so just check the description of this video for those other videos. Okay, and that's it for the general lighting load portion after those demand factors. I like to draw a very clear line that clearly distinguishes this section in its own section here, and then I'm also going to label it. Normally, after doing those demand factors, I'm going to have a total number. So I would write that total number for this section, and then I'll label what section it is, which is the GLL, and I'll give that a nice circle so I can glance at this section real quick and I can see this is the GLL. Of course, it normally contains a number in it. It's very clear. One thing to point out is when you're working with multifamily, if your volt amps go over 120,000, when you go to the demand factors, there's going to be a certain number you get from your first 2 sections. I'll call the magic number. And I'm going to make a separate video on that. So also look for the magic number of load calculations. After finishing that general lighting load portion, we're getting into the next portion, which are going to be appliances. If you already know how to do appliances in your load calculations using the standard method, then you're already going to know how to do this. But one thing you really need to pay attention to is the amount of appliances that you have are always going to be multiplied by the amount of units that you have. In other words, if you only have 2 appliances in each one of these dwellings, it's, let's say, pretty small and has 2 little appliances. Well, if you have 6 units, now you have 12 appliances when you're doing your load calculation for all these multifamily dwellings, because you're not just doing it for one of them, of course. That's why we're calling it a multifamily, because we're including all of these different dwellings. Okay, and we're going to need to look at Article 220.53. Okay, and that's going to tell us if we have 4 or more appliances, they're going to be rated at 75%. And this is if they are 500 watts or a quarter horsepower or greater. And that leads us to the fact that if the appliances are less than 500 watts or a quarter horsepower, there's just not going to be demand factors, meaning that if we have appliances under those ratings, we're still going to include them in our load calculation at 100%. We're just not going to get them at 75%. This is important because you might have an appliance that is 450 watts or maybe a 6th horsepower motor. And like I just said, no matter how many of those you have, those are going to be rated at 100% because you don't have demand factors. But they're still going to be included. Of course, because of that, you can create 2 different sections off of this, and you can separate the appliances that are 500 watts or a quarter horsepower or greater. Those are going to get the 75% demand factor. You have those in their own side of this section, and then let's say the next side of this section, you do the ones that are less than 500 watts or a quarter horsepower, and that's because one side's going to get those demand factors, one side isn't. You can do them separately, and then you can add them together. When you add them together, you're going to get your total number for appliances. It's going to make a lot more sense when I do an actual example. That is all for this section. The thing to really pay attention to is that no matter how many appliances you have, you're going to multiply it by the amount of units that you have. Okay, so I'm going to circle appliances. Normally, like I was saying, I'd have a number here. So I'd actually glance at this and see, okay, my appliance section has this number that I'm going to add all together at the end to get the total number, which is what they're going to call the total demanded load for the dwelling. Okay, and the one thing I really like to do is have my in parentheses times the amount of units. That's what this is going to represent. If I had 15 units, this would say multiply it by 15 in parentheses. Okay, so I have that in the general lighting load section right here. And I also have that in my appliances section right here. I'm going to have that in every section, as you see by the time I fill out this summary of how to fill this out and of the rules. But when I start to get into the example, there's going to be numbers here, and you're going to see I'm still going to do that. Every section is going to have its total number circled and labeled, and it's also going to have in parentheses multiplied by that amount of units. You really want to do this so you can glance at each section and see that you did not miss out on multiplying by the amount of units. And at the same time, things might get a little complicated if, for example, if you have 2 air conditioning units per dwelling, and then you have 4 units for a multifamily, then you're going to need to multiply your load for an air conditioning unit by 2, because you have 2 air conditioning units per dwelling. And then you have 4 dwellings in that example. So now you're going to need to multiply all that by 4. So it's just easier to keep track of when you can see, okay, you multiplied it by 2, and then there's the parentheses multiplied by 4. I only do the parentheses, which signifies the units, so you can clearly see you did not forget anything, you didn't make any mistakes. Okay, after moving on from the appliance section, we get into the next section, which is HARD, which is really like 3 sections, and I'll show you why. First, you have the HA. I like to draw these close to each other because you're going to pick the bigger one. So let's say you had a bigger air conditioning system, then you do a heating system, then you're going to pick your AC, and you're going to disregard your heating, and this is when you're adding everything together at the end. And the biggest thing to get away from this is that you need to multiply by the amount of units that you have when you're dealing with every single section here. Like I said, this is like 3 sections here. So we have the heat or AC, you pick the bigger one. You need to multiply by the amount of units when you're getting that total number. And for the heat and AC in standard method, you're just going to get those at their rating. You don't have demand factors telling you to derate these. Then we have R and D. R is for range, D is for dryer. So we have hard, HARD. That's why I'm saying it's 3 sections, because We pick the bigger one here, so that's one section. Then we have range and dryer left over. And for ranges, we do have demand factors. We're going to want to go to table 220.55, and we're going to want to look at the column that corresponds with the rating that we have for our appliance. And then where it says number of appliances, that's going to line up with the column. And of course, you're only going to use the number of appliances when you have multiple appliances all at the same rating. This is a little bit of a tricky table to use, and like all the stuff I'm going to mention in this video, the first video really explains in depth a lot of this stuff. And I could explain how to do this, but we're going to get into it. The explanation is going to be a lot more complicated than doing it. All we got to know is we got to check for those demand factors, and when we actually go to applying those demand factors, we want to make sure that we kept in mind that we multiplied the appliances that we have by the amount of units that we have, which is also, of course, going to tell us the number of appliances that we have. So there's those two things. We have the demand factors and the number of units for the range. There's a little more to dryers when we get to multifamily, because dryers, according to Article 220.54, have a 5 kilowatt minimum rating, or nameplate rating, whichever one is greater. So they have that 5 kilowatt minimum. Of course, we need to make sure we're multiplying by the amount of units that we have when we're doing all these different sections, but we can't get too ahead of ourselves because we also have demand factors here for dryers, and that is at table 220.54, where we can see that if we have 5 or more dryers, we're going to have a demand factor. We see 5 dryers, we have an 85% demand factor. 10 dryers, we have a 50% demand factor. Okay, so for dryers, you have to make sure you have that 5 kilowatt minimum or nameplate rating. After picking the bigger of those numbers, you need to multiply by the amount of units that you have, and you need to make sure you apply those demand factors. Don't try to wrap your head around this too much, because it's going to serve you a lot more good to actually just do an example and actually just fill it out. The more of these examples and practice questions that you do, the more that you're going to understand this. What this is really going to be helpful for is you can come back to this video at any point and you can refresh on all this. So from a year now, 2 years from now, you get kind of foggy about this, you don't remember, and you wrote this down somewhere and you can't really remember where you put it, you can just think, okay, there's that Jared V. Electric guy. He made that video on this. You can just look up my channel, look up the video, and it can serve as an organized way to find this information. I'm almost done, and then I'm going to move my head out of the way. So if you want to screenshot it or take a good look at it, I'm going to have some seconds of just the whiteboard by itself without my head in the way of it. Then we need to go to Article 220.60, and we see in gray here in 2020, it mentions 125% of the largest motor shall be used in the calculation. And because it's gray, that means that's new to this edition. So that's the part to where if you're using the 2017 version, then you're not going to have this. Okay, because I know some states are still on the 2017 version for whatever reason. So that's where you find it in the book, and that gets me to the next rule, the final rule. Again, you got to really pay attention to this. And that is the 25% of the largest motor. We're only going to do that one time, no matter how many units we have. And this is for standard method, duplex, and multifamily. No matter how many units we have, we're going to take 25% of our largest motor. This is when we're looking at our appliances. We're going to add that at the very end, but we're only going to do that one time, no matter how many units we have. If we're dealing with a single family, we do that one time. If we're dealing with a duplex, we do that one time. If we have 8 units, 10 units, 15 units, it doesn't matter. We're going to do that one time, and that's only for the 25% of largest motor. So you can see where I did the amount of units, X units for each section, except for this last section. You really need to keep that in mind and remember that. And that's for the 25% of the largest motor. And I mentioned if they said there's no housing loads, and that's really odd. That's for multifamily dwellings. And what they mean by that is you're not going to include anything that's outside of the individual house or the individual dwelling. So any outside hallway lighting, any outdoor public pools for the residents of that multifamily dwelling, let's say apartment complex, the office building where you have to sign the papers when you're getting signed into, let's say, that apartment complex, and any other things you could think of that are outside of the individual dwelling. So recreational areas, let's say you have a gym, and anything else that you could think of, even like I mentioned, the outdoor lighting, not on the actual dwelling, in the hallways and stuff like that, going up the stairs. You're not going to include that in your calculation if you have information about that and they tell you to not include your housing load. Okay, so I don't know why they call that housing load, because you're basically doing a housing load here. That's what we're doing. So if you see that come up at any point, you're going to know what to do. It's only for multifamily dwellings. So if they mention that and you're not at a multifamily, it's totally irrelevant. And the only thing that might actually be relevant would be if they're telling you to not include your laundry load, which you'll see in my part 3 video of the residential load calculation. You'll see an explanation of where to find those exemptions in the codebook. Okay, now I'm going to move my head out of the way. And now if you want to take a good look at this, you're going to have some seconds to screenshot this or write this down or whatever you need to do. Okay, now we're going to get into the next section where I'm going to show you an example and I'm going to fill it out with you and we're going to get the answer together. Okay, so it's good to know when there is a question asked, if it does not mention standard or optional method, you're going to be using the standard method. Okay, so I'm not going to mention it in the question because that's more realistic. It will mention if it uses the optional method. Okay, and just so no one gets confused with what I just said, just to really clear things up, I'm doing the standard method right now. Find the minimum overcurrent protection device for the following multifamily dwellings. You have a 10-unit multifamily dwelling and you have the following loads in each of the units. Each dwelling is 1,000 square feet. It has an 8 kilowatt heating system and an 8 kilowatt AC system, a 6,400 watt range, a 4 kilowatt dryer, a 4 kilowatt hot water tank, a 1 kilowatt dishwasher, a 0.8 kilowatt disposal, a 450 watt fan, and a 6th horsepower motor. Okay, the first thing to do when we're dealing with anything more than a single family is to somewhere on the paper very clearly identify the amount of units that we're going to be working with. Again, I do in parentheses times the amount of units. We had 10 units. It's going to keep things pretty easy because we're going to do everything times 10. As we know, it's pretty simple, but we're going to get all the experience of doing a multifamily load calculation. It's really good to start simple. Okay, so I'm also going to do an exclamation point right here, just so that at the end, of course, I double check what I'm doing. I'm going to see this in the corner, and I'm going to make sure every single section has that times 10. Again, it's also pretty simple because for square footage of the house, each dwelling is at 1,000 square feet. Okay, and of course, we're going to multiply that by 3 volt amps, but I'm not going to get into that yet. That's the furthest I'm going to go with that. I'm going to now divide that section and leave enough room for the amount of math that I'm going to need to do. Okay, so I know I'm going to need to do a good amount of math here. So I'll draw a line about right here. And now I'm going to fill out the rest of the information in the question. This way I can do one thing at a time and eliminate any mistakes. I can fill out everything that the question asked me. I can double check it and make sure I didn't leave anything out. And then I can get into each individual section, solve it. I can even double check each individual section, and then I can go back at the end, of course, and add each section up individually. And then I can do that a second time because everything is separated. And I do know this line looks a little bit crooked, so I'm going to be hopefully fixing it a little bit. It's a little bit difficult when it's super wide. Okay, so we filled out the fact that we have 1,000 square feet per each dwelling. Of course, we know we're going to have 10 units. Now we get into the appliances. Of course, sometimes the question isn't going to ask everything in order, and I do appliances next, so I'm going to just do everything the same way each time, no matter how the question asks it. This is going to make it a lot less confusing for me, actually. Okay, so I see I have a hot water tank, a dishwasher, a disposal. I can see that those are each of my appliances that are 500 watts or a quarter horsepower or greater. I'm going to put those all in their own section. And I have a 4 kilowatt hot water tank, a 1 kilowatt dishwasher, and 0.8 kilowatt dispo. So as you can see, I'm filling in each of these in the same order that the question was in when I get to the actual section, so I can just go through it in order and not have so many complications. Okay, so now I'm going to get into the other appliances. We have a fan and a motor. I'm going to keep in mind that I'm going to do some math here, but since I have 2 sections, I'm just going to divide this about halfway through. Okay, so we have a fan and we have a motor. The fan is 450 watts and the motor is actually a 6th horsepower. Now, it doesn't tell us voltage, it doesn't tell us anything else. What we need to know is we're working with a dwelling unit, so we're going to be using single phase, and then they don't tell us 240 volts, so we know that for a dwelling unit, we're going to have 120 volts if they're not going to mention the fact that we have 240 volts. And that is when they're just telling us that they have a 6 horsepower motor. So it's specific to this exact situation, having a motor. Okay, so we know it's 120 volts, so we're going to get in a table. When we solve this, we're going to find out how many amps a 6 horsepower motor is, and we're going to have to multiply that by 120 volts. That'll give us our watts. So then we can have our number. Okay, what we really need to pay attention to is the amount of units. If we separate each of these sections, we need to first think of why we're separating them. That is because this left section is appliances that are 500 watts or quarter horsepower or greater. That means that 4 or more appliances are going to be rated at 75%. Okay, we simply see that we have 3 appliances here. If we multiply that by the amount of units that we have 10 units, then we're working with 30 appliances here. It's that simple. And that is just in this left section right here. Okay, and the rule is 4 or more appliances are at 75%. So obviously 30 is more than 4. Okay, and because of that, when we get that total number from all these appliances, I'll just draw a line right here. We need to multiply that by 10 because of the amount of units that we have. That's going to equal, of course, another number we're going to put right here. And then we're going to multiply that by 75%, in other words, 0.75. Okay, now when I go to fill that in, I'm not going to forget any of those steps. Then we go to the right side of the appliances here. Of course, these are all going to be rated at 100%, so that's why they're in their own section. But we don't know the rating of the motor yet. We're going to have to figure that out. So I know we're going to have to do some math, but at some point, we're going to have to multiply everything that we have by 10, because we have 10 units. Okay, now obviously know that when I get both of those numbers, I'm going to add them both together, and that'll be the total number for this appliance section. I'm going to draw another line that's dividing this section. Okay, now I'm going to get into the next section, HARD. Of course, I might be filling some of this out a little differently, probably a lot more vertically if I'm using a portrait style piece of paper, because I'm using the landscape view here to fit the screen that you're watching. I'm kind of doing everything a little more horizontally. So just keep that in mind if you have a paper in portrait style. So it's the long way up and down. Then a lot of this stuff is going to just be going down instead of like have it sideways. Okay, so next section we get into the hard, H-A-R-D. And I'm going to give myself plenty of room. I have H-A-R-D and I have room to be able to do the math to figure out each of these. Of course, when you're doing this yourself, you can write a lot smaller than me and you might have more room, but for the video, I'm going to be writing bigger. Okay, so we're told we have an 8 kilowatt heating system and an 8 kilowatt air conditioning system. These are the same exact kilowatt, so we're probably just going to pick the bigger one. And yep, exactly. We're going to pick which one we want. We need to remember, of course, multiply each section by the amount of units that we have. So we don't have 8 kilowatts. We have 8 kilowatts times 10. So we have 80 kilowatts. And that's actually this whole section. So I'm just going to label that heat real quickly. And I'm going to circle this. So now I know that this section is actually already solved. Next, we go into range. We're told that we have a 6,400 watt range. Make sure you always label things watt, so then you don't go somewhere along the way and forget to label horsepower, amps, or something different. And you confidently know each time what you're working with. Okay, we're going to go into table 220.55. We're going to keep in mind the fact that we have 6,400 watts per appliance, and we have 10 units, so we have 10 appliances. With that in mind, we're going to look at column A, B, and C, and see which one of those aligns with our individual rating. We see column B is 3.5 kilowatts through 8.75 kilowatts. So obviously 6.4 kilowatts fits in that. So we know we're using column B, and all we have to do from there is look at the number of appliances, and we see 10 appliances. That tells us we have a 34% demand factor, and above we see demand factor tells us a percentage. So this is telling us to take a percentage of our total load, and that is going to be our answer for this section. I want to write down the fact that we're going to calculate everything at 34%, and I'm just going to do a squiggly little circle around it So then you can see that it's not a legitimate circle. That's just my method of doing it. Okay, so now we're just going to take our rating of the appliance and the amount of appliances that we have. We have 6,400 times 10, which gives us a total of 64,000 watts for all of those 10 appliances. Now we're going to multiply that by 34%, or in other words, 0.34. And we're going to get 21,760 watts. And of course, that's going to be that calculation for the range. Again, I hope this isn't confusing because I'm not starting from the very top right now and doing all that yet. It's pretty straightforward, so I'm just doing this part as I go. We still have the 25% of the largest motor. So I mean, I guess just following along with this is just going to keep you on your toes a bit more. I'll again do a little squiggly line here, separate the section. Now we have the dryer. We were told we had a 4 kilowatt dryer, and we know we need a 5 kilowatt minimum. That turns into 5 kilowatts, and then we know we have 10 units. So we're going to multiply that by 10. That's going to give us 50 kilowatts, but remember we have demand factors for our dryers if it's 5 or more. So we're going to go into that table 220.54, and we're going to see with 10 units that we have a 50% demand factor. Okay, so that's pretty straightforward. We're going to multiply that by 0.5. I guess I'll again circle that in a squiggle just so I can see the fact that, okay, I did do the demand factor here. We could probably do that in our head, but it's always good to use a calculator. We get 50 kilowatts times 0.5 or 50%, and we have 25 kilowatts. Okay, now we know the total number for our dryers. Of course, it's circled and labeled. Okay, we can't forget about the 25% of the largest motor, so I'll give that its own little section here. Again, I'm writing big, but at the end of it, I can erase some stuff, and I'll make it work. Okay, so 25% of the largest motor. Of course, this is the only section that we're not multiplying by the amount of units that we have. Okay, now let's fill out the rest of it. As we can see, since I separated everything in sections, it's not really a big deal which section I start off with, because we can still see the sections that aren't completed. Okay, I'm going to start from the top down. We know our dwellings are 1,000 square feet. We know we multiply that by 3 volt amps. It's going to give us 3,000 volt amps, and we're going to add that 4,500 volt amps for the 2 small appliance branch circuits and 1 laundry circuit. That's going to give us 7,500 volt amps. We're going to multiply that by the amount of units we have. We have 10 units. So 7,500 times 10 equals 75,000. You can see it's real easy because I'm using 10. Okay, and of course I'm going to label it watts. Watts and volt amps are the same thing here in load calculations. We're not thinking about power factor or anything like that, so we can use those interchangeably. Okay, and now we're not done because we still have demand factors. So I need to make this work with the amount of room that I have. So I'm going to take this 75,000 watt number, and I'm going to start working with that over here. Okay, so I have 75,000 watts. Right off, I'm going to look at this and see that I'm not over 120,000 volt amps. Or like I was just saying, watts. See, I'm using it interchangeably. Okay, because table 220.42 has the demand factors. For dwelling units, we know the first 3,000 is at 100%. And then from 3,001 to 120,000 is at 35%. Again, we're not over 120,000, so we're just going to stay within those 2 categories right there. Because of that, we're going to subtract by 3,000. Think about this like you're putting it off to the side. And this is because we literally will put this off to the side here. We're going to have 3,000 watts, and I'll label this at 100%. Okay, I'm going to make that pretty clear for myself. And then we have 72,000 watts left over from 75,000 minus 3,000. From there, we're going to multiply that 72,000 by the 35%, and we're going to get 25,200 watts. Again, I'm running out of some room, so make sure you're following along and you wrote this down, okay, because I'm going to erase some stuff right here. Now we're going to take this 25,200 watts that we just got, which was our 3,001 to 120,000 watts at 35%. Then we're going to take our first 3,000 watts at 100%, and we're going to add those both together. 25,200 plus 3,000 is 28,200. And that is our total number for the general lighting load portion. I'm going to label it, and I'm going to circle that label with my total number. Okay, now that we finished the general lighting load, we're going to go into the appliance section. Okay, now we're going to get into the next section, the appliance section. Probably going to see, now I filled this in. There was a photo over this before. I accidentally put slightly wrong numbers for this, so that's why it's really good to double check. Okay, now I'm going to keep everything kilowatts to keep it simple. We have 4 kilowatts plus 1 kilowatt plus 0.8 kilowatts. Okay, so pretty straightforward. We have 5.8 kilowatts. And then we have the amount of units. We have 10 units because I already wrote all this down. Now we have 58 kilowatts. We're going to take those 58 kilowatts and multiply it by 0.75. We're going to get 43.5 kilowatts. And I'm just going to draw a little squiggly circle around this because this is just the answer for this left section here with that 75% demand factor. Okay, now I'm going to go into the right side there, and I see that I have the motor at a 6 horsepower, and I still don't know the rating for that motor. Because of that, I'm going to go into my book. I'm going to go into the motor full load current tables, and I'm going to be looking at table 430.248, which tells me my full load current in amps for single phase alternating current motors. Again, we know it's single phase because we're working with single family, and we know it's 120 volts because we weren't told 240 volts. We see a 6 horsepower under 115 volts is 4.4 amps. Okay, but you might be saying that says 115 volts there, and now I'm telling you to multiply 120 volts. And I don't want to tell you to flip all around the book, but that's what I'm going to be doing right now. You're going to want to go to article 220.5 calculations, section A, voltages. Here it tells you that we're going to be using nominal voltages here for our service load calculations. We see we're using 120 volts, 240 volts, 208 volts, 347 volts, 480 volts, 277 volts, and 600 volts, and those are the only variations of voltages that we're going to be using. We see they are grouped sometimes together, but those are the only voltages we're going to use. Therefore, if we're doing our service load calculation, and we see in a table right here, 115 volts, well, we need to know that here in our load calculations, we're using nominal voltages according to what it tells us in that article. So we're using 120 volts, even though we found that under the 115 volt section. Therefore, you see the 230 volt section as well. Okay, and that's not one of your nominal voltages, so you're going to have 240 volts. So we know we have 4.4 times 120. It's going to give us our watts. So we have 528 watts. Okay, but that's only telling us the rating for that motor. Now we have to add the 450 plus 528, and we're going to get 978. And then, of course, we're going to multiply that 978 by 10. And we're going to get 9,780 watts. And that is for this section of the 100% no demand factor appliances. Now we're going to have to add 9,780 watts plus 43.5 kilowatts. Of course, now because we have 9,780 watts, we're probably going to want to convert 43.5 into 43,500. So let's do 9,780 plus 43,500. We're going to get 53,280. I have no idea where I'm going to write this, so I'm just going to erase right here. Okay, and I'm going to write it very big. Draw a big circle around it. I have 53,280 watts, and it's labeled as appliances with a big old circle around it. Now I can glance at this section and see it's done. I can also glance at this section and the other sections so far, and I can see, okay, general lighting. We did the times 10. Of course, I erased stuff, but just imagine you see everything still, and we have the times 10. We have the demand factors. We did the minus 3,000. We're not over 120,000. We see it's at 100%. We did the 35%. We added those together. We can glance at that and we can see that, yes, we added that to get that. So these little things can make us more confident, and we can also double check and maybe catch any mistakes. We see for appliances, we have our left section of appliances, the 75% demand factor. We see the times 10, and I erased the 75% demand factor, but again, imagine it's still there. So you'd look at that and you'd see, okay, that's all there. That section's done. We also see the total number for that section. We go on to the right side, we see that I solved the load for the motor. I added those together. I got my number. We can eyeball that and see, okay, that looks correct. We multiplied that by 10. Obviously, we can eyeball that. And we can see that, okay, 9,000 added to 43,000. And we have 53,000. Everything's looking pretty good there. And what I'm doing here is, like I said, catching any mistake. If I all of a sudden see 49,000 here, then something wouldn't be adding up. Okay? Again, I already picked the heat or the AC. They were the same, so I just picked whichever one I wanted. I also see I multiplied the number by 10. I have the range. I see that I multiplied the number by 10. I also see I have my demand factor, and I use the demand factor to get that total number, which is labeled for the range. I see the dryer. I see I have that 5 kilowatt minimum. I see that's multiplied by 10, which is my amount of units. I have 50 times 0.5, 25. I can see, okay, everything's adding up. Obviously, I still need to do my 25% of my largest motor, but now I can confidently say I did everything else correctly. Now, when we're talking about the largest motor, this is a little interesting. We're not talking about what is the largest rated appliance that contains a motor. We're talking about what is the largest appliance that for its main function uses a motor. As we see, the dishwasher is 1 kilowatt, and the disposal is at 0.8 kilowatts. Now we can logically think a dishwasher probably has some motors in it, but when we compare that to a disposal, we can see that the disposal uses a motor as the main function of that appliance. So we can see in this situation, we actually have the dishwasher at a higher rating, but we're going to pick the disposal because the disposal actually uses a motor for the main function. So we're going to have 800 watts, and we're going to multiply that by our 25% or 0.25, and we're going to get 200 watts. Okay, I'm going to circle that. Of course, it's in its own section. That's super obvious. I mean, I literally do label everything, so I'm just going to actually label it 25%. It'll be super obvious. I even go a step further and put LM. Just like 25% LM. Can't miss it. Super obvious. Now I need to add everything together, but I don't have any room. So I'm going to have to erase some stuff. I'm going to get out of the way. So if you want to screenshot this or take a good look at this and write some of this stuff down, I'm going to give you that chance. And then I'm going to erase some stuff. We're going to add everything together and get our total number. Then we're going to find our minimum size over current protection device. Okay, so if you need to take a good look at it, here you go. Okay, so now I have a lot more room. Of course, normally I wouldn't have erased everything. I'm going to add everything together, but first I'm just going to double check that each section is done. I know I have a general lighting load section, that's done. I know I have an appliance section, that's done. I know I picked the heat or the AC, and I have a heat. And then I know I have the range and the dryer, I see both of those. And I have 25% of the largest motor. Everything is there. Now I can add up all the numbers and get my total number, which they call the total demanded load for these dwellings. So I'm going to get 28,200 plus 53,280. Then I'm going to add 80,000 and then 21,760. Then 25,000 and last 200. Okay, I'm going to write down that total number I just got, and I got 208,440. Now I'm going to add everything together a second time. I'm going to spare you from that, but imagine I just added everything together again. I took my time and I got the same exact answer. Okay, I got 208,440. Of course, these are watts. And now we have the total demanded load in watts. I like to put my final answer in a box, so I'm going to box this. But the question was asking for the minimum overcurrent protection device. So to find that, we need to find the amps. We have volt amps here. So to find amps, we're going to simply divide by 240 volts. 208,440 divided by 240 gives us 868.5. Okay, now according to article 220.5 calculations, part B, fractions of an ampere, when we get to the ampere section of our load calculation here, then we're going to round up to our nearest whole number. Fractions that are smaller than 0.5 are going to be rounded down. So it's just like we know how to round any fraction in life normally. If it's 0.5 or over, we round up. If it's less than 0.5, we're going to round down. So we see it's at 0.5. So we're going to round up. So because of that, our 868 becomes 869. And of course we have amps, but we're not done yet. I can tell right off the bat, 869 amps is not a standard rating for a breaker. to find our standard rating for our breakers, we're going to go to table 240.6a. There we see all of our standard ampere ratings. Since we had 869, we're going to look for that. We see 800 and we see 1000. Okay, we normally are used to rounding up to the next size overcurrent protection device, and that's just what we're used to doing. But what we need to keep in mind is what the code book is telling us to do. If we look at article 240.4, section B, it tells us that overcurrent protection devices rated 800 amps or less are going to take the next standard rating. Okay, so in other words, if we're in the middle of a number, we're going to choose the next higher size if that next higher size is 800 amps or less. Because of this, we see we're at 869. Okay, so we have 800 and 1000 here for the standard ampere ratings in table 240.6a. Therefore, we're not going to round up to 1000. In fact, we're actually going to round down to 800. Okay, so we have an 800 amp overcurrent protection device. That is our minimum overcurrent protection device for those multifamily dwellings. Now you can think about how this makes sense, because when you're going up to your next standard size of your breaker, what you're doing is allowing there to be more power supplied to the dwellings, because the breaker is going to tell you the size of wire that you need to accommodate that breaker, and then also how much power you can put on those wires. So in all, we could say, okay, it makes sense to not actually round up, and maybe because of all the other demand factors, when we're 800 amps or less, it would make sense to round up just to be able to give us sufficient enough amount of power. But then that gets kind of complicated, because you start to think about understanding why they're going to do it the certain way and why they're not going to do it a certain way, and you come to an understanding of, okay, this code book is written a little bit weird, and you kind of just need to know where to find the rules and know how to follow them versus trying to understand it, because it's not like something that's very understandable. Okay, so we found our minimum size overcurrent protection device, and that's what the question was asking us. So we're completely done. We found our answer, and although some people might think that you're going to round up to your next size overcurrent protection device regardless, we could see that the code book tells us we're only doing that if that next size is 800 amps or less. Now this is something that I've even seen in multiple practice questions where they completely miss this when you get over 800 amps, and they just round up to the next size no matter what. Okay, but you need to know that those people who are going to be writing the actual test that you're going to take are going to know the code book a lot more than the people who are writing your practice questions, who probably have an entrepreneur mindset, who are trying to give you something that's valuable and of course make an income off of it. Okay, so that's just basic business. They're providing you with something valuable, you're giving them money. But what I've noticed in a lot of these practice question books you can buy, no matter who you're getting it from, not going to name any sources or names, but in basically all of them, I find mistakes somewhere along the way that just shows that they're not really double checking what they're doing and making sure that there aren't mistakes. Of course, they're probably doing this pretty well, but they're not doing it well enough, because I've found enough mistakes where I've wasted a lot of time trying to figure out why I can't get a certain answer, and then I actually am able to identify the mistake. And this is a problem, because I'm supposed to have someone teaching me, and there's a mistake in that. So that's part of the reason why I'm making all these videos. I really double, triple, quadruple check all of this stuff to make sure there are not any mistakes. So when you're following along, you can do everything, you can get all the correct answers on your calculator, you can add everything up and get the same answers, and you're not going to be sitting there confused, not knowing if you got taught something incorrectly or if you're doing something incorrectly. It'll be very straightforward. Okay, and I'm not going to be able to do these videos forever because I need to make money. So if you do want to support me making these videos, just let me know in the comments down below, and then that'll be something that I'll consider, because there's a lot to learn with the code book itself. But I feel like from what I've been teaching on my channel, I'm basically have been teaching enough to be able to pass the test that you need if you're trying to get certified. In the next portion of my channel, I want to be looking at real life more. Planning projects, structuring certain financial situations, income, the pricing of certain goods, and a lot of the things that are going to be a part of running a business. So if you'd like to see more content like this and more of the content that I just described, Be sure to subscribe so you know when I post these videos. Feel free to leave any comments if you're confused about anything, if you have any questions, if you really would like for me to make a video about something. Obviously, this channel is not very big, so I'm going to see every single comment. And if you're not respectful, I'm not going to want to work with you, so make sure you're respectful if you want me to work with you. That's the end of this. If you got use out of this video, give this video a thumbs up to show me that you liked it. Share this with other people that'll get use out of this. And maybe just put a random comment to help me out in the algorithm, maybe, so someone else will come across this video. The whole point of this channel is to help other people out. I have a philosophy in life that it's a lot better to share your privileges and success with the people around you so you and the people around you are all thriving versus trying to hog everything for yourself. Because I know we're a lot stronger together than we are separate. Make sure you don't do any of this too much to where you get too much of a headache or frustrated or anything. This all takes time, and I will assure you that the first few times you do this, it'll seem kind of cloudy and kind of confusing. And if you just keep doing these over and over, it might continue like that. You need to give yourself a break. You need to plan some amount of time. If you don't have time, then too bad, but you hopefully do, and you're going to have to give yourself some time to take a break, to think about this stuff, then to go back to this, try to fill out another question, and try to, pull the stuff out of your memory, find the things that you need to find in your code book. And that's where you're going to start making the connections on your own. You're not going to have to ask anyone or look at any videos. And after doing this enough times, this is going to be so simple, because like how I showed you where I categorized in certain sections, standard method. I just have general lighting load. I know I have 3 volt amps per square foot. I know I have demand factors. I know of appliances. I know the certain sizes are 4 or more at 75%. Heating and AC, range dryer, 25%, working with the standard method. Okay, so pretty simple. And you just are plugging in numbers. So this is the official ending of this video. Take care, and until next time, goodbye.